Welcome to the Cisco Networking Academy Intro to Networks course. This is Module 17, Build a Small Network, and this is the last module in this course. In Module 17, we're going to look at devices in a small network applications and protocols, scaling to a larger network, verifying connectivity, hosting and iOS commands, troubleshooting methodologies, and troubleshooting scenarios. Devices in a small network. The majority of businesses are small and their networks are going to be small too, so you need to become familiar with setting up small networks. A small network design is usually pretty simple. It usually consists of some type of router, maybe a switch, and then you've got host devices. You're probably going to have a printer set up. You're going to be dealing with DHCP and maybe some other small issues, so we'll take a look at that in this module. Small networks typically have a single wide area network connection or a gateway, a single gateway provided by your DSL cable or an Ethernet connection to your ISP. Large networks require an IT department to maintain, secure, and troubleshoot network devices and to protect organizational data. Small networks are managed by a local IT technician or contracted by a professional. Like large networks, small networks require planning and design to meet user requirements. Planning ensures that all requirements, the cost factors, and deployment options are given due consideration during the planning process. One of the first design considerations is the type of intermediary device to use to support the network. What type of router are you going to have? Is it going to be one that's provided by the ISP? Is it going to be one that's purchased by the small company and put in place? So factors that are considered when selecting the network device should be cost, speed and types of ports interfaces, the expandability, and then operating system features and services, and then who has to support that. IP addressing for a small network. When implementing a network, you need to create an IP addressing scheme and use it. All hosts and devices within an intranetwork, they must have unique addresses. Devices that will factor into the IP addressing scheme include how many end user devices, the number, the type of connections. Do you have wired? Do you have wireless? Are you going to have remote access? Are users going to be using VPN to get to the connections? Servers and peripheral devices, printers, security cameras, intermediary devices, including switches and access points. And I would also include in there that will the company be allowing bring your own devices? Will employees be bringing their own devices and putting them on the network, their own phones, their own personal laptops, things like that. So that needs to be put into the consideration as well. It is recommended that you plan and document and maintain an IP addressing scheme based on device type. The use of a planned IP addressing scheme makes it easier to identify a type of device and to troubleshoot the problems. Now, redundancy in a small network, it is expensive to create redundancy. So in order to maintain a high degree of reliability, redundancy is required in a network design. It does help eliminate single points of failure. Redundancy can also be accomplished by installing duplicate equipment, and it can be accomplished by supplying duplicate network links for critical areas. Traffic management. The goal of a good network design is to enhance the productivity of the employees and minimize network downtime. The routers and switches in a small network should be configured to support real-time traffic, such as voice and video, in an appropriate manner relative to other data traffic. A good network design will implement quality of service. Priority queuing has 4 queues. The high priority queue is always emptied first. So you have FTP would be a low priority, instant messaging, SMTP would be about the middle band, and then voice would be a high priority. And video traffic, anything along those lines would be high priority. Small network applications and protocols. After you've set up your network, there's still certain types of applications and protocols that need to work. The network is only as useful as the applications that are on it and running. There's 2 forms of software programs or processes that provide access to the network. Network applications, that's applications that implement application layer protocols, and they're able to communicate directly with the lower layers of the protocol stack. And then application layer services, for applications that are not network aware, the programs that interface with the network and prepare the data for transfer. Now, some common protocols in a small network. Network administrators commonly require access to network devices and servers. The 2 most common remote access solutions are Telnet and Secure Shell. If you're going to be working with a small company and you're not on site, this is most likely going to be one of the ways that you get into the network to diagnose things. You're going to be able to get into the devices, and so you're going to should be able to have it set up where you can get into at least secure shell. Hypertext Transfer Protocol, HTTP, and HTTPS. Those are used between web clients and web servers. SMTP, it's used to send mail, or POP3 or IMAP. FTP, if you need that. If not, turn FTP off if they're not going to be using FTP services. Secure File Transfer Protocol are used to download and upload files between client and an FTP server. But if you're not doing that, or if you're not using that service, turn those ports off. DHCP is used by clients to acquire an IP configuration from a DHCP server, and DNS to resolve domain names to IP addresses. And a server could provide multiple network services such as DHCP, SSH server, and DNS if you needed an internal DNS server. The network protocols, these below comprise the fundamental tool set of a network professional. Processes on either end of the communication session, types of messages, syntax of the messages, meaning of informational fields, how messages are sent, and the expected response, and interaction with the next lower layer. Many companies have established a policy of using secure versions, SSH, SFTP, and HTTPS of those protocols whenever possible. Voice and video applications. Business today, especially this video is being recorded in July of 2020, and as everyone by now is aware, Corona or COVID or whatever name it's being called by is something that's happened to the world, and it's caused a lot of companies to send their employees home to work from home. So voice over IP is even more critical now than it was a year ago in 2019. So businesses are using a lot more IP telephony, streaming media to communicate with customers and business partners, as well as enabling their employees to work remotely. The network administrator must ensure that proper equipment is installed in the network and that the network devices are configured to ensure priority delivery. The factors that a small network administrator must consider when supporting real-time applications are infrastructure. Does it have the capacity and capability to support real-time applications? Voice over IP, or VoIP, is typically less expensive than IP telephony, but at the cost of quality and features. IP telephony, this employs dedicated servers from call control and signaling and real-time applications. The network must support QoS mechanisms to minimize latency issues, real-time transport protocol, and real-time transport control protocol, or RTCP, and two protocols that support real-time applications, or those are two protocols that support real-time applications. Scaling to larger networks. Growth is going to happen with companies, or hopefully it's going to happen with a company. That's the goal of most companies, is to get larger and grow their business. It's a natural process for many small businesses to outgrow the network that was created for them. The network administrator should have enough lead time to make intelligent decisions about growing the network in alignment with the growth of the company. To scale a network, several elements are required. Network documentation, again, back to that documentation point, both physical and logical topology. Device inventory, knowing what you have, a list of devices that uses or compromises the network. A budget, an itemized IT budget, including fiscal year equipment purchasing budget. Traffic analysis, protocols, applications, and services and their respective traffic requirements should be documented. Protocol analysis. It's important to understand the type of traffic that's crossing the network as well as the current traffic flow. There's several network management tools that can be used for this. You can capture traffic during peak utilization times to get a good representation of the different traffic patterns. Wireshark is a good tool for that. You perform the capture on different network segments and devices, as some traffic will be local to a particular segment. Information gathered by the protocol analyzer is evaluated based on the source and destination of the traffic, as well as the type of traffic being sent. And that analysis can be used to make decisions on how to manage the traffic more efficiently. So once you if it's a new network, once you get it up and running, you want to do some traffic patterns during peak times, peak usage times, and you want to document that with the rest of the network documentation. And you also, if you're coming into a network that's already pre-built, you want to do some traffic pattern utilizations or some utilization tracking to see where it is, to see where you could possibly improve that network. Employee network utilization. Many operating systems provide built-in tools that allow snapshots of information, the OS version, CPU utilization, RAM, drive utilization, non-network applications, and network applications. You also want to help document that snapshot information with the networking. You may not think that goes with the networking part, but it does help, because if you've got Windows operating systems versus Linux operating systems versus Macs that are being put on the network, those are going to make and the type of work that they're doing as well. If they're doing heavily intensive video two-way conferencing, that's going to take up more network traffic than someone just working on word processing documents or spreadsheet documents. Next, you want to verify connectivity. You can verify connectivity with ping. Whether your network is small or new or large and you're scaling on an existing network, you will always want to verify that your components are properly connected to each other and to the internet. The ping command, available on most operating systems, is the most effective way to quickly test layer 3 connectivity between a source and destination IP address. The ping command uses the ICMP, echo ICMP type 8, and echo reply ICMP type 0 message. So you can echo, or you can ping. Here we're pinging 10.1.1.10, and if it sees 10.1.1.10, it gets a reply back. On a Windows 10 host, the ping command sends 4 consecutive ICMP echo messages and expects 4 consecutive messages in reply. The iOS ping sends the 5 ICMP echo messages and displays an indicator for each echo reply received. iOS indicators are as follows. You can do the exclamation mark. That indicates successful receipt of a message. It validates a layer 3 connection. A period means that the time expired waiting for an echo. And an uppercase U indicates a router along the path responded with an ICMP. Sometimes when you do the ping command, if it's a new connection and lines have just came up, the first ping may not work. So it's a good idea to ping a second time before you say something's wrong. The Cisco iOS offers an extended mode of the ping command. Extended ping is entered in privileged exec mode by typing ping without a destination IP address. You'll then be given several prompts to customize the extended ping. And note here that pressing enter accepts the indicated default values. The ping IPv6 command is used for IPv6 extended ping. You can look at the example here if you want to pause the video and look at the examples there, or test it out on your router in your packet tracer, or if you've got a router that you're working with or a switch, you can do that as well. Or on your desktop client, you can also work with the ping command. You can also verify connectivity with traceroute. The ping command is useful to determine quickly if the layer 3 layer 3 is connected or if you have problems. However, it doesn't identify where the problem is located. So traceroute can help locate areas in the network or locations in the network where you're having problems. A trace returns a list of hops as a packet is routed through the network. The syntax of the trace command varies between operating systems, so it's tracecert or traceroute, and it's different on Linux versus Windows versus the iOS. The following is a sample output of tracecert in Windows 10. Use the Control-C to interrupt the tracecert in Windows. If it gets locked up, you can do a Control-C. If not, this one looks like it's timing out. This was an example here of on a router. So it's doing the route trace here, and you're getting routes going. On the left, the trace validated that it could successfully reach PCB. On the right, 10.1.1.10 host was not available. The output shows asterisks where replies timed out. Now, Windows implementation of traceroute sends ICMP echo request. Cisco iOS and Linux use UDP with an invalid port number. Final destination will return an ICMP port unreachable message. Like the extended ping command, there's also an extended traceroute command. It allows the administrator to adjust parameters related to the command operation. The Windows tracecert command allows the input of several parameters through the options in the command line. However, it's not guided like the extended traceroute iOS command. So the following below is a display of the available options for the Windows tracecert. You can do does not resolve. You can do maximum hops. You can do a timeout. You can do a traceroute trip path. You can force IPv4 or force IPv6. The Cisco iOS extended traceroute option enables the user to create a special type of trace by adjusting parameters related to the command operation. In privileged exec mode, you type traceroute with a destination IP address. iOS will guide you through the command options by pressing a number of prompts or presenting a number of prompts related to the setting of the different parameters. And pressing enter accepts the indicated default values. Network baseline One of the most effective tools for monitoring and troubleshooting network performance is to establish a network baseline. One method for starting a baseline is to copy and paste the results from an executed ping, trace, and other related or relevant commands into a text file. These text files can be timestamped with a date and saved into an archive for later retrieval and comparison. And among items to consider are error messages and the response times for the host-to-host. Corporate networks should have an extensive baseline done, more extensive than we can describe it in this course, and it goes way above this course, but professional-grade software tools are available for storing and maintaining baseline information. Host and iOS commands. In Windows 10, you can access the IP address details from the Network and Sharing Center to quickly view the 4 important settings: address, mask, router, and DNS, or you can issue ipconfig. You can do that at the command line of the Windows computer. Use the ipconfig /all command to view the MAC address as well as the number of details regarding the layer 3 addressing on the device. If a host is configured as a DHCP client, the IP address configuration can be renewed using the ipconfig /release and then typing ipconfig /renew commands. The DNS client service on Windows PCs also optimizes the performance of DNS name resolution by storing previously resolved names in memory. The ipconfig /display DNS command displays all the cached DNS entries on a Windows system. You can also do an ipconfig /flush DNS, which will flush your local DNS cache if you're having trouble with DNS. IP configuration on a Linux host. Verifying IP settings using the GUI on a Linux machine will differ depending upon the distro that you have. So in the command line, though, you can do an ifconfig to display the status of the currently active interfaces. The Linux ipconfig command is used to display addresses and their properties. It can also be used to add or delete IP addresses. The output displayed may vary depending on the Linux distribution as well. In the GUI of a Mac host, you want to open up Network Preferences Advanced to get to the IP addressing information. You'll type ifconfig or ifconfig command to get the information. Other useful Mac OS commands are network setup, list all network services, and the network setup -get info. The ARP command, ARP, is executed from Windows, Linux, or Mac command prompt. The command lists all devices currently in the ARP cache of the host. The ARP -A command displays the known IP addresses and MAC address binding. The ARP cache only displays information from devices that have been recently accessed. To ensure that the ARP cache is populated, ping a device so that it will have an entry in the ARP table. So you want to ping first and then run the ARP display. The cache can be cleared by using the netsh -interface -IP -delete -ARP cache command, and then event the network administrator wants to repopulate the cache with updated information. You will need administrator access on the host to be able to use the netsh command. Some common show commands. Show running config verifies the current configurations and settings. Show interfaces, interface status. Show IP interface shows the layer 3 information. Show ARP, your ARP table. Show IP route, layer 3 routing information. Show protocols verifies which protocols are operational. And show version, which is going to give you your memory, interface, and license information of the iOS. Show CDP neighbors command. CDP provides the following information about CDP, Charlie Delta Papa, neighbor device, device identifiers, the configured host name of a switch, router, or other device, address list, up to 1 network layer address for each protocol, port identifier, the name of the local and remote port in the form of an ASCII character string such as fast Ethernet 0/0, capabilities list, whether a specific device is a layer 2 switch or a layer 3 switch, platform, the hardware platform of the device, and the show CDP neighbor detail command reveals the IP addresses of a neighboring device, and you can see that down here. The show IP interface brief command, that command provides an abbreviated output for the show IP interface command. It provides a summary of the key network information for all the network interfaces on a router. This is an examples here below. We can do show IP interface brief. Troubleshooting methodologies. There's 6 steps in the troubleshooting, basic troubleshooting approaches. And it's common across if you do the CompTIA A+ exam, if you do other computer repair, if you do troubleshooting, if you're in software design, all of these basic steps are going to come into play. So this is something that you really need to know. and I can almost guarantee you that you're going to see these on an exam, almost guarantee. So you want to memorize these 6 steps, not word for word. You want to memorize and understand the process. So step 1 is you want to identify the problem. What is happening? Get all the facts. This step is the troubleshooting process. This is where you're going to be talking to clients. You're going to be trying to diagnose what was going on at the time. What was the last thing that they did? Was there a power surge? Was there software installed? Did anything get updated? Was there anything weird happening with the internet different than it had happened before? Those are the types of questions you're going to be asking. Then you want to establish a theory of probable cause. What do you think is going on? It doesn't necessarily have to be correct at this point. It's just what do you think is going on? So after the problem has been identified, though, you want to try to establish a theory of probable causes. This step often yields more than a few probable causes to the problem. It may be 3 or 4. You may be saying it could be 1, 2, 3, or 4. Let's start testing those, and that's step 3. Test the theory to determine the cause. You want to start, and I usually start with the most simple solutions first. So I can say, did it have power? Was there a power surge? Did somebody step on a cord and unplug a power cord? Simple things, and then work up from there. So a technician may apply a quick fix to test and see if that solves the problem. If not, you move on to the next problem. If a quick fix does not connect it or does not correct it, then you move on. Then you want to establish a plan of action and implement the solution. So you've identified the problem, you've come up with some probable causes, you've tested the theory. Now what you're going to do is you're going to establish a plan. And I want to just put a note here is you don't want to just go in and start trying to fix things without proper documentation and without making sure you're 100% sure that you know what solution that you're going to apply is going to work. I've worked with some IT people in the past that what I call shooting from the hip, the old American Westerns where they would just shoot from the hip and they would work and they would just actually make problems worse by trying to solve things. I've done it myself a few times where I get in a rush and I'll try to apply a solution. Oh, I know what that is, and it ends up not being that. So you want to make sure that you're 100% sure you know what the problem is. That's where you establish a plan of action, implement the solution. Then you verify your solution and implement preventative measures. You make sure that what you put in place works. Verify full functionality. Check with the end users. Don't just assume that they're up and running. Check with them, verify that everything is up and running, and then implement whatever measures need to be put in place to keep it from happening again. If somebody stepped on a power cord, make sure that doesn't happen again. If there was a brownout, make sure that you start discussing with the business about putting some type of device in place to keep brownouts from happening, a brownout with the power. And then you want to document. I know documenting sometimes for me, it's frustrating. I'm not a big person that likes to document, but it's important in this whole process. You want to document your findings, your actions, and your outcomes because you may not be the person that works on it the next time. Or 6 months from now, you may not remember what happened. So you want to make sure that it's properly documented. It is important for future reference. Resolve or escalate. In some situations, it may not be possible to resolve the problem immediately or quickly. A problem should be escalated when it requires a manager decision, some specific expertise, or network access level unavailable to the troubleshooting technician. A company policy should clearly state when and how a technician should escalate a problem, and don't spend too much time trying to resolve an issue so that it becomes a problem. Learn to escalate as soon as necessary. I will tell you personally, this was one of the things that I had difficulty learning when I was first started working in IT. I would, what I call a pit bull, I would grab onto a problem and I would try to solve it and I would be like, I'm going to solve this. And I would spend so much time that I was not escalating like I should. I should have called for help earlier. And through the process of learning, and I had people, train me and teach me, and I had some good teachers that, hey, at some point you need to say you're costing the company money and you need to escalate this. And it's actually cheaper. And it's about getting the uptime back, getting that company back up and running. So it's not about you solving the problem. It's not about your ego. It's about getting the problem solved and getting everybody back up and running. The debug command. The iOS debug command allows the administrator to display iOS processes, protocol, mechanism, and event messages in real-time analysis. All debug commands are entered into privileged exec mode. The Cisco iOS allows for narrowing of the output of the debug to include only the relevant feature or subfeature. You can use debug commands only to troubleshoot specific problems. To list a brief description of all the debugging commands, you can use the debug space question mark in the privileged exec mode at the command line, and you should test that out and practice that. To turn off a specific debugging feature, add the no keyword in front of the debug command. And alternately, you can enter the debug form of the command in privileged exec mode. To turn off all active debug commands at once, use the undebug all command. Just be cautious with some debug commands, as they may generate a substantial amount of output and use a large portion of system resources, and they can, if we're working on a router and you start taking up resources and it's a live production router, it could cause some problems, so you want to make sure. The router could get so busy that displaying debug messages that it would not have enough processing power to perform its networking functions and even listen to commands to turn off debugging. Debug and certain other iOS message output is not automatically displayed on remote connections. So this is because log messages are prevented from being displayed on VTY lines. To display log messages on a terminal virtual console, you want to use the terminal space monitor privileged exec command. To stop logging messages on a terminal, use the terminal no monitor privileged exec command. Next, let's take a look at a few troubleshooting scenarios. Interconnecting Ethernet interfaces must operate in the same duplex mode for best communication performance and to avoid inefficiency and latency on the link, so that's one thing you want to check. The Ethernet auto-negotiation feature facilitates configuration, minimizes problems, and maximizes link performance between two interconnecting Ethernet links. The connected devices first announce their supported capabilities and then choose the highest performance mode supported by both ends. If one of the two connected devices is operating in full duplex and the other is operating in half duplex, a duplex mismatch occurs. So while data communication will occur through a link with a duplex mismatch, link performance will be very poor. So duplex mismatches are typically caused by a misconfigured interface, or in rare instances by a failed auto-negotiation. The duplex mismatches may be difficult to troubleshoot as the communication between devices still occurs, and it's hard to figure out what's going on. IP address issuing on an iOS device. Two common causes of incorrect v4 assignments are manual assignment mistakes or DHCP-related issues. The network administrators often have to manually assign IP addresses to devices such as servers and routers and printers. If a mistake is made during that assignment, then communication issues with the devices are likely to occur. That's why you want to check everything after you've set up your IP addresses. Don't just assume that everything's working. On an iOS device, use the show IP interface or show IP interface brief to verify what v4 addresses are assigned to network interfaces. And for example, issuing the show IP interface brief command as shown below would validate the interface status on R1. IP addressing issues on end devices. On Windows-based machines, when the device cannot contact the DHCP server, Windows will automatically assign an address belonging to the 169.254.0.0/16 range. This feature is called the Automatic Private IP Addressing, or APIPA. A computer with a APIPA address will not be able to communicate with other devices in the network because those devices will most likely not belong to the 169/16 network. Other operating systems such as Linux and OS do not use APIPA. If the device is unable to communicate with the DHCP server, the server cannot assign a v4 address to the specific network and the device will not be able to communicate. To verify addresses assigned to a Windows-based computer, use the ipconfig command, and if you see that 169, you know that APIPA took over and it did not get an IP address. You can have default gateway issues. The default gateway for an end device is the closed networking device belonging to the same network as the end device. It can forward traffic to other networks. If a device has an incorrect or non-existent default gateway address, it will not be able to communicate with other devices in remote networks. It won't be able to get out of its local area network. Similar to v4 addressing issues, default gateway problems can be related to misconfiguration in the case of manual IP assignments, or DHCP problems if the automatic assignment is in use. To verify the default gateway on a Windows-based computer, use the ipconfig command to see what the default gateway router is, or on a router, do the show IP route command to list the routing table. The route is used when the destination address of the packets does not match any of the other routes in its routing table. Troubleshooting DNS issues. It's common for users to mistakenly relate the operation of the internet link to the availability of the DNS. So DNS server addresses can be manually or automatically assigned via DHCP. On my home network, I have them manually DNS. I don't let my ISP configure my DNS servers. I put those in manually on my internal network. And it is common for companies and organizations to manage their own DNS network. Any reachable DNS server can be used to resolve names. Cisco offers OpenDNS, which provides secure DNS service by filtering phishing and some malware sites. OpenDNS addresses such as 208.67.222.222 or 208.67.220.220. Advanced features such as web content filtering and security are available to families and businesses. And you want to use the ipconfig /all to show the verify the DNS, and you can set those manually on the Windows clients or your clients, or you can set those up to the DHCP server. The NSLookup command is another useful DNS troubleshooting tool for PCs. With NSLookup, a user can manually place DNS queries and analyze the DNS response. Okay, so this has been Module 17. What did we learn? A lot. We learned factors to consider when setting up a small network. When implementing a network, you want to create IP addressing scheme. You want to make sure that things are redundant. You want to make sure that the routers and switches in a small network can be configured to support real-time traffic. You want to make sure that you can scale the network. You want to make sure that your network is documented. We also looked at the ping command, the iOS extended ping command. We looked at trace routes, trace route tool. We looked at the ipconfig tool. We also looked at the ARP tool. We also looked at show running config and show interface brief. We looked at show CDP neighbors, show IP interface brief. We also looked at some common problems that you might need to diagnose in your day-to-day. That is not by any means the only number of issues you'll have, but those are some common ones. Okay, well, I hope this series was helpful for you. If it was, make sure that you click the like button below. Make sure you subscribe to my channel. Just remember to be safe and be excellent to each other. Hope you have a great day.